analog to digital converter is measuring from 255 to 0, and the voltage is from 5 to 0. So all we need to do is figure out how to do that conversion, and we'll have an accurate voltmeter. So let's make a new thing called volts. It'll be equal to level divided by 255 times 5. So we'll chop it up into 255 pieces and then multiply that by 5, and that should give us the conversion, shouldn't it? Since they both start at 0, I think that's all we need to do. And then instead of printing level, let's print volts. Let's put a little message here. This is volts. There we go. Okay. Hey, look. The voltage that we're getting is 3.2 blah, 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 long decimal point, but it's the same beginning as here, 3.2. So it's working like a voltmeter. Now if we drag it up, let's try this, pull it up to a higher voltage. Now we're reading 4.8. Hey, on our voltmeter, we're reading 4.8. So we made a little voltmeter. Now it looks like it's super, super accurate, but actually it's probably not really that accurate because we only have 8 bits. So this is probably rounding nonsense. If we were going to clean it up a little bit, we might make it so we don't show quite so much. Remember how we can kind of do that trick to do the rounding? Let's do that right here. We'll say volts equals math round volts times 10 divided by, whoops, that's not divided by 10. So I multiplied it by 10 and then rounded it, and then I divided it by 10, so we'll have 1 decimal place. It's kind of a little trick you can use in JavaScript to round to the nearest tenths. Okay? And then again, I'm still going to print it. So let's reset it here. Hey, 4.8. And if I pull this down, get 4.3. Let's go to a lower voltage. Let's pull it down to, like, how about 0.4 volts? Hey, 0.4. So that's a pretty good little voltmeter, isn't it? And remember what's going on here. We're taking in an analog measurement on